In this video, we're going to be taking a look at dynamic ARP inspection. Now, dynamic ARP inspection validates ARP packets in a network. It intercepts, logs, and discards ARP packets with invalid IP to MAC address bindings. It protects the network from certain man-in-the-middle attacks and determines the validity of an ARP packet based on valid IP to MAC address bindings stored in DHCP snooping binding database. So basically what it does is it's what they refer to as a request and reply protocol. It says, what is 1.1.1.1's MAC address? And the reply to that would be 1.1.1.1 is all A's. Now this is only available for IPv4. IPv6 leverages ICMPv6, which this is typically referred to as duplicate address detection. Layer 2 switch capability, and it's enabled per VLAN. So one of the things that it's going to help guard against is unsolicited ARP replies, or what they refer to as gratuitous ARP or GARP, which basically is a ARP message that is given out by a device that was not asked for. That's what they call unsolicited. So I commonly refer to this as unsolicited as the way the NAT works, where if you don't already have a NAT translation in the NAT table, incoming traffic from the outside or from the internet won't be allowed to go back through the device. ARP spoofing is very similar, and it allows the attacker to sniff the network by basically telling everybody to come to him. Dynamic ARP inspection configuration, this is enabled on the VLAN. And when it comes to statically assigned IP addresses, you're going to use a static ARP ACL and configure the ports facing the device as trusted. And dynamic ARP inspection does not inspect ARP packets on trusted ports. So that's pretty much it for how that works. Let's go ahead and actually configure it and see how it actually comes into play. So actually I've got to go and erase all this stuff. So what we're actually going to be doing is, this is going to help prevent against invalid ARP messages. If you hadn't already caught that, you guys are smart, I'm sure you did. So let's say, for instance, remember we're taking a look at port security. This is going to be like port security's big brother, where port security is going to take a look at what's going on in the network and it's going to say, okay, well, I see XYZ going on, where if for some reason R2's MAC address changes, that would be an indication that there might be something in the network going on that needs to be taken a look at. So, case in point, if you're changing your MAC address to try to get around, maybe you've got some sort of 802.1x or MAC authentication bypass, where you're trying to do some sort of, like, what's a good word for it? Network access control, where what I can do is I can come in here with switch 3, and I can go in here. I can type in IP ARP inspection, and I can say VLAN 10, 20, 30, and hit the enter key. And then I have to go to interface. Let's do a do show CDP neighbors. Interface range gig 3/1 through 3, and type in IP ARP inspection trust. Now, by doing that, what's going to end up happening is that's going to prevent ports that are throwing bogus MAC addresses out. So I'm going to do the same thing on switch 4. Actually, I'm going to go to switch router 2 real quick, and I'm going to go to global config, interface, fastly send at 0/0, IP address is DHCP, and router 7 is the same. We're going to go to switch 4, show CDP neighbors, and show VLAN brief. I'm going to put 3/2 back into VLAN 20. So interface gig 3/2, switch port access VLAN 20. So 7 should now receive an IP address. Well, 2 should receive an IP address, and he did, which is awesome. Everything is awesome. Okay, cool. So 2 should have an IP address, which he does. So now I get to go to switch 4, exit out, type in IP ARP Inspection VLAN is going to be 10, 20, 30, and interface range gig 3/1 through 3, IP ARP Inspection Trust. Okay, so that's how this comes in. Show IP ARP Inspection. So what it's going to do, it's going to take a look at all the stuff in the network. So I can get very specific if I want to. I can say VLAN 10. It's going to give me some 10 stuff. So it's enabled, it's active. The ACL is deny. Now mind you, there's nothing going on here that I have that's statically configured. What I can do is I can go to one of these ports. If I do a show IP DHCP snooping for VLAN 10, snooping database for binding VLAN 10, and I see on gig 3/1 and switch 4, which goes down to I forgot who's got that port. So show CDP neighbors 3/1 router 5. So router 5 is this MAC address. If I go here and I do a go to router 5 and I go to MAC address is AAAA.AAAA.AAA5, I go up here to switch 4. Now you're receiving invalid ARPs. Okay, so what it's basically telling me is invalid ARP request on gig 1/0 VLAN 10. This was the received MAC address here with this IP. The known MAC address is this guy, right? So what's happening here, I'm sorry, no, this is this right here. This right here is going to be router 1. This is router 1. This guy down here anyway, that's what it's seeing, and that's a bad sign. It's seeing that coming in, and it shouldn't be that way. So I tried to go out and ping 10.1.1. or 10.1. Oh, do ping. Repeat 10. It's not going to work. You're going to continue to see traffic coming in on that port, and it's going to be like, that's no bueno, dude. You can't do that. This is dynamic ARP inspection because DHCP snooping already had this enabled. So by me coming in here and on R5, I've got these 10 packets going out. So now I come in here and do a show IP DHCP snooping binding for VLAN 10. It's not going to let me learn the new MAC address. It's actually going to prevent the traffic from flowing. And the reason why is by typing do show ARP, it's telling me that this is my MAC address. Well, this MAC address here differs from this MAC address here. Those two don't match. So if I go back to router 5 and I come in here and I do no MAC address and I do a do show ARP, the MAC address changes to that. Now I go try to ping, I go to switch 4, it's not going to trigger it. Oh, you know what? I bet you I had to. You know what I forgot to do? I forgot to enable it on all the important ports, like the uplinks. So interface range gig 0/1 through 3, gig 1/0. That's why you see these ARP requests. I was like, why is that coming in the way? I have to type in IP ARP Inspection Trust. Do show history. Grab this command right here. Copy it to switch 4. Global config. And Voila. So now we got that. If we go back to router 5, try to do that ping again. Boom. So that's how that comes into play. Show IP ARP inspection. And now we have packets being sent. Things are on the up and up. But that's one of the things to keep in the back of your mind. It's, are you being diligent in your network? And I mean, it's one of those things where having the visibility is very, very important. And this is where that comes into play. Not a whole lot here, guys. I wasn't going to do anything static. But if you wanted to get in here and do static stuff, you would actually have to come in. I think it's a MAC access list extended. You could actually match on what they call an ARP ACL. So you type it ARP, and under here you could say permit any, or you could say this would be actually a deny from any source MAC to a specific destination MAC. Let's say you could specify, let's say for instance, I want to do a show ARP, and I want to grab, I'm on R2, R2's IP address is .30, which means on R1 I want to be grabbing, well, it doesn't make a difference. They're all pretty much the same. Well, it's not true, they're not completely the same. Deny that MAC address, and I can match on multiple. Incomplete command. Mask. Destination MAC address mask. FF. Or is it all Fs? Do show run pipe include or begin MAC or include MAC. I don't do this every day. I'm still trying to. Does section work? Deny any. Oh, that's because I don't want to do that. Or is it? That's what I was looking for. Deny host. So let's go ahead and pull this guy out. No deny any. But I want to do a permit any. So then I would go to, in this particular case here, interface. Actually, you know what? This is only supported. Interface range gig 0/1 through 3, gig 1/0. This is probably not going to work. MAC access group, ARP, and that's what I thought. Yeah, it's inbound. The logic is different here because I have to match on the traffic coming inbound. I forgot about that. It's got to be applied ingress, where the logic here would be incorrect. And the reason for that is because from an R2 to R1 perspective, from a traffic forwarding perspective, traffic is going to be going towards R1, where the destination MAC address would be R1's fast Ethernet 0/0.30 MAC address. I would have had to put, no, wait a minute. That actually might work on this guy. Let's go interface, do show CDP neighbors, interface, gig 3/2, MAC, access group, ARP, in. I'm pessimistic here. Show MAC, access group, interface, gig 3/2. Okay, ARP is enabled, so let's go ahead and go to 2. he has an IP address, so let's try to do ping. And what's the IP address here? 10.1.30.1. I'm not confident that's, yeah, I didn't think so. Switch 4, show MAC access group. Show access list ARP. Yeah, see, it's the destination here is this host, but what's happening here is the logic is backwards because it's inbound. Well, no, that would make sense. I'm arguing with myself here. This would not be done here. This would be done on switch 1 inbound from switch 3 or switch 2. That's where you'd put it, because it's always going to be inbound for where it's got to go. But we'll cover that in CCIE for security. This is a little over the top for CCNP, but that's basically how it would come into play. So if I was to actually do a show run section access, let's steal, I'm just curious here. Let me go to switch 1, interface range gig 0/1 through 3 gig 1/0. My God. We're going to type in MAC access group ARP in, and that's going to prevent any traffic coming in from, so show access list. So traffic is already being permitted to go through. So if I go back to R2, maybe it's actually working. Oh, it is working. Okay, well, hey, I was not actually prepared to make that work. So in this case here, it is working. So I was right. The logic was incorrect earlier. Where the logic idea here was pretty simple. R2 wants to send traffic to R1, but you have to match. You can't match on the directly connected hop, because switch 4 is actually R2's first hop switch. So first hop simply meaning traffic from R2 goes directly to switch 4. That means it's first hop. Even though switch 4 is not a layer 3 device, there's no IP address, but from a MAC learning perspective, switch 4 is the first switch to learn the MAC address of R2. But the way that the inbound ACL works is upstream of that. And switch 1 receives that traffic inbound, and we can continue to do the ping here. Repeat 10, and go over to switch 1, and you're going to see this number increment repeatedly, and that's exactly what you were going to. That's what you should see. Now, because when I originally put it on there, I'm like, okay, let's put it as close to it. But then I thought about it. I've done this before, one time in production for something, and it's one of those things, you don't use it but like once a year if you're lucky. So I'm familiar with the concept. It's just a matter of actually applying it to the port and getting it to apply correctly. But it is working. So it's always the switch above you, and you can only apply a MAC ACL inbound from the traffic. So you have to wait until the traffic is actually in transit. Now, could I have done it on like switch 3 or switch 2? I could have tried, but because switch 1 connects directly to R1, it made more sense to put it there. But that's basically how a static ARP ACL comes into play, where you would do that. And that's a layer 2 ACL. You're not matching it on an IP address, you're matching it on a layer 2 MAC address. So keep that in mind as you're moving forward. Until next time, guys, thank you so much for stopping by, and we'll catch you guys in the next video.